Welcome to yet another video on SRID Cloud. In this video, I want to talk about IPSec Tunnel. IPSec Tunnel is a term used in networking to ensure the communication between one part of the topology to the other part of the topology in a secure way. So let me explain. Let's take a look at this topology. There are two networks here. The Los Angeles network connected to San Francisco router and the Boston network connected to the New York network. And the routing are all in place in Los Angeles, San Francisco, New York and Boston. And the San Francisco and New York routers are connected through Chicago. So I'm basically simulating the internet with the help of the Chicago router. So there is an internet between San Francisco, Chicago, and New York. And any traffic going through San Francisco, through Chicago to New York is not by default encrypted. So if you know the traffic, then you can easily find out what is what, who is talking to whom, and to some extent you can get some data if it is not, if the data is not encrypted. But what is not desired is the Los Angeles computer trying to talk to Boston should only be localized to the Los Angeles and Boston networks. You do not want anybody above San Francisco and above New York to even have any clue of what these two are talking to each other. There is a way to accomplish this, and one of the ways to do this secure communication is with IPSec Tunnel. So in this topology, I have connected the Los Angeles computer to San Francisco through a switch. And this is on 192.168.1.0 network. On the Los Angeles side is the 192.168.1.2, and its gateway is on the San Francisco side, 192.168.1.1. Similarly, on the eastern side, Boston and New York, they are connected through a switch, and they are on 192.168.2.0 network. The Boston is on 192.168.2.2, and its router 192.168.2.1 is in New York. And the San Francisco and Chicago, they are connected with 172.168.1.0 network, and the IPs are 172.168.1.1 on the San Francisco side and 1.2 on the Chicago side. And similarly, New York and Chicago are also connected through its own network 172.168.2.0 with the IP 2.1 on New York side and then 2.2 on the Chicago side. So now there is a routing in place. A Los Angeles computer 192.168.1.2 can talk to 192.168.2.2 Boston straight away. So that is made possible in this topology to keep things simple. On San Francisco router, there is a default route, send all unknown traffic to Chicago. Similarly, on the New York side, send all unknown traffic to Chicago. And on the Chicago network, there is a route to 192.168.1.0 network as through San Francisco, and 192.168.2.0 network through New York. So this can be done in a different way. Instead of hard coding these default routes, which I will show in a moment, we could have employed BGP or OSPF on San Francisco, on Chicago, and New York routers, but that's not the purpose of this video. So this video, my purpose is to establish a very clear route from Los Angeles to Boston in a very in a clear text fashion. But now that is not desired. So I would like to create what is called an IPSec tunnel between San Francisco and New York. So there are two reasons for this. One, I do not want anyone above San Francisco and New York line to have any idea of what data is getting transmitted. I want that data to be encrypted. And at the same time, I do not want anyone north of San Francisco and New York to know what is the source IP address and what is the destination IP address of this transfer, the traffic transfer. That is also possible with the the tunnel mode of IPSec configuration, which we will see in a moment. If for some reason, if you do not want to hide the IP addresses of the source and destination, then we can switch over to a transport mode of IPSec, and that will still encrypt the data but will make the IP source and destination IPs visible. But in this video, I kept the IPSec tunnel mode as confidential, in the sense tunnel mode. Okay. So now let's go and take a look at the topologies, the configurations one by one. Let's go to Los Angeles first. The IP address on this is, as I said earlier, it is 192.168.12, and its gateway is 192.168.11. And now let's go to Boston. And let me do show IP, and it shows 192.168.22, and its gateway is 21. So now let's take a look at what is configured on the San Francisco router. On San Francisco router, I configured the IPSec tunnel. Let's see how that is done. Let's look at the running configuration. So the San Francisco has the southern network 192.168.10 with 11 IP address, and 172.16.11 to Chicago simulated internet with 11 IP. And now let's look at the running configuration. And let's skip all these things. So the first thing that is configured on this router is the crypto ISACMP policy 5 being the priority number, can be anything from 1 to 10,000. And then the encryption. So what algorithm do I want for this encryption? I could have picked DES or 3DES or AES, AES 192 or AES 256. I just picked AES. You can pick whatever. And then the so that will offer the confidentiality cryptographic assurance, and to provide the integrity cryptographic assurance, I picked SHA-256. The other option is MD5. And for authentication cryptographic assurance, I picked pre-share, the PSK. I could have picked the RSA, public and private key encryption as well. But for this video, I picked pre-share. And then the group 2 is the Diffie-Hellman group. The options are 1, 2, and 5. And finally, the lifetime, the 28,800 seconds. So the routers, San Francisco and New York, which is going to be configured in a similar way, I will show you that in a moment, they will negotiate all the cryptographic parameters every 28,800 seconds. So if there is any change, then that can be effective after the time frame. And finally, I'm also setting the password, the ISACMP key password, as get labs done, and I'm associating that address to the 172.16.2.1, which happens to be the northern IP address of the New York router. So what does this mean? This means anything between San Francisco and New York needs to be encrypted with these cryptographic parameters. And since we are using pre-share key, the PSK mode, I have provided the password, get labs done. So that means the same password needs to be used on the other end as well, which we will see in a moment. So what we have done so far is the IKE policy setup in the ISACMP framework. So this is phase 1 where the ISACMP or IKE policy is set up. And now we are going to switch over to the IPSec phase 2. And for that, the first step is to create the transform set. I just gave a name branch1 set. And I picked these cryptographic parameters, ESP AES and ESP SHA-256 HMAC. There are several combinations available which can be understood from the router manual. And I set the mode as tunnel, as I mentioned a moment ago. The other option is transport, the difference being the source and IP addresses will be hidden through the tunnel mode, and it will not be hidden, it will be revealed under the transport mode. And finally, I'm creating a map. This is the phase 2 I'm in. Branch 1 map is name of the map that I created under the scheme of ISACMP. And I set the peer as 172.16.2.1, which is the IP address of the New York side. And I'm also associating the map to the transform set, branch 1 set, and a couple of other parameters. So now this map needs to be set on the northern interface of San Francisco, which is connected to Chicago. That we will see in a moment. There it is. So the Gigabit Ethernet 1 is the interface connected to Chicago, that is to the internet actually, whose IP address is 172.16.1.1, and the map is associated to that. So this is it. This is how the IPSec or IKE and IPSec under the ISACMP framework is configured on the router. So rest of the configuration should be very easy to understand. This 192.168.1.1 is on the Gigabit Ethernet 2 facing southern direction, and nothing on 3 and 4 interfaces. And as I said earlier, I have a default route on this router to send everything to Chicago if the particular traffic is not understood by this router. And I missed this one, so I have also set up an access list. This is a very interesting and important point. This is called the interesting traffic setup. That means only data originating or terminating to 192.168.1.0 network needs to be encrypted. Others will not. So for example, there could be another network, 192.168.3.0 network connected to San Francisco. Any traffic from that network through San Francisco will not be encrypted at all. So this method is used to limit the data coming from a particular network. So where is this access list used? I mean, should be somewhere here. Here it is, match address 100. So match address 100 is the reference to the access list 100. IP access list extended 100. So this is an important concept. You do not want to encrypt everything going through San Francisco. You are encrypting only a particular network traffic. So now nothing else to look at. And now let us look at the configuration in New York, which should be very identical. So there it is. Now let's look at the IP assignments. So 172.16.2.1 towards Chicago and 192.168.2.1 towards the Boston network. So now let's look at the running configuration. I'm going to skip all these things and go to the same thing. Whatever we saw in San Francisco should be here, but the IP addresses are reversed. So now the peer is 172.16.1.1. That is IP on the San Francisco side, and everything else should remain the same. And I'm using the same password get labs done here as well. and the crypto map is applied to the northern interface of the New York towards Chicago, and everything else should be identical. Here is a static route, and the default route, and here is the access list, and only traffic coming from Boston will be encrypted and nothing else. No other network, not shown here, but if there is any other network connected to New York, will not be encrypted at all. So now let us also look at Chicago, just for the sake of academic interest. And let me do so as expected, it has two interfaces on it, 172.16.1.2 towards San Francisco and 172.16.2.2 towards New York, and the running configuration should not be of any interest, but let's look at it anyway. So the gigabit Ethernet 1 and 2, they're all configured. 3 and 4 should be nothing, and there are a couple of default routes. One to the not the default route, sorry, this is the static route. One to 192.168.10 network, the Los Angeles network, via 172.16.1.1, that is San Francisco, and another route to Boston, 192.168.20 network via New York, 172.16.2.1. That's it. So now let us do some tests. Let us go to Los Angeles and try to ping Boston from there. So ping 192.168.2.2, and it starts working. I observed that with IPSec Tunnel on, the ping is taking longer. Without the IPSec, obviously there's no encryption and decryption, so the time taken for the traffic to flow through is a lot quicker. So now I want to show you a couple of things. I'm going to attach a monitoring tool on the network between Chicago and New York. Let us do that. And I will also monitor the traffic between New York and Boston. And let us look at both of them simultaneously. One on the sides. There's already some traffic going on the second interface. We need to ignore that for a moment. And now I'm going to go to Boston, and I'm going to ping the same thing, like 192.168.2.2. So I'm pinging all the way from Los Angeles to Boston. This network should get encrypted, but only up to New York. So the traffic flowing through Chicago to New York should get encrypted. And let us see what happens to the traffic from New York to Boston. So as you can see, the traffic from Chicago to New York, they are tagged as ESP instead of ICMP. So this is the encrypted traffic. And notice that interestingly, it does not carry the source IP as 192.168.2.2. It is actually showing this traffic as if it originated from San Francisco and going only up to New York. So this is how the IP address of the source and destination are actually hidden from the view through the IPSec. But on the network, on the transaction between New York and Boston, nothing is hidden. This is straightforward plain text ICMP protocol, with the source IP as 192.168.1.2 and the destination 192.168.2.2. So anyone looking at this traffic below New York, between New York and Boston, they can see what is going on. But anyone above New York, or actually above San Francisco as well, will not have any clue of what is going on between Los Angeles and Boston. They will not even know that the data is originating from Los Angeles. So for them, whoever is north of New York and San Francisco, they will think as if San Francisco and New York, they are talking to each other. But that is not the case here. So two very important benefits of IPSec tunneling. One of them is the hiding of the IP addresses, and second, the data. Data is getting encrypted and decrypted on either end. So now let me go back to this original topology diagram. You can see green colored line between San Francisco and New York, and that is that logical connection between them, otherwise called the IPSec tunnel. So most importantly, the actual bits flow from San Francisco to Chicago to New York, but logically they flow from San Francisco to New York directly. I hope you enjoyed this video, and I'll produce a lot more videos in the near future. And thanks for listening, and thanks for watching as well. And bye for now.